hopefully. Yep, we are on the air. Elliot?
Yes, sir.
Elliot, welcome. We just went on the air.
All right.
Let's see, I'm gonna make the pictures smaller. So I thought you guys might enjoy a little humor. Did you see the slide that's up there? You get what's going on there. You know how, kids, when they're using poor English, use double negatives like, I ain't got no cookies. Which of course means he's got some. But, so see, this professor says, hey, there's no language where a double negative actually means a positive. And I love this comment from the back of the room. Yeah, right. Actually, that slang term that we all use really is it's a double positive that actually means a negative. So it's kind of ironic. Okay, let me open it up. 3.1, 3.2. Do you have any of the assigned problems that I gave you that you think we should take a look at? Welcome, Susan. So one more time, right now I'm just looking for any questions from the two lessons that we had last Wednesday. 3.1 and 3.2.
Could we do one of the truth tables from 3.2?
Yes, we sure can. Which one did you have in mind?
27.
Okay. So I've set up number 27 here. I put some of the book problems, so it's a good thing because I'm caught here without my book today. So this is a perfect setup. So anyway, number 27 is up there on the top in the book. Just circle it here. And then I've got it down below here. So it wants you to do a truth table for P inclusive or not Q. So because we only have two letters, we know that we needed what? 2 to the 2 power or 4 rows. So I did the standard setup here, half and half, true, true, false, false, and then go by ones, true, false, true, false. Okay? Over here, I didn't have to do this, but I copied the T table from over there. The P table. I don't know, every once in a while, let me check on my mouse, my pointer. Hang on a sec. I maybe have to put a new battery in this thing. Because I keep jostling, and that seems to work. So what I did here, let's see if we have it. Yeah, I just copied the P table from over there. And then here, I put not Q, which is just the opposite of the Q column on the left. So instead of TF, FT. And then above the black arrow, I applied the rule for inclusive or. You remember the rule? It was what? Only false when both are false. So true, false, that should be a true. True, true, they're not both false, true. False, false, they are both false, so that one's a false. And false, true, they're not both false, so that one's a true. So basically, that column, that's it. Truth table complete. Now, that's in the back of the book. They may not have that for the style, but that should be the final result.
Okay.
Other questions?
Number 11.
Okay,
Uh,
number 11, you got it.
11C in particular. I saw the answer, but I wasn't sure how they got to that answer, or just what the.
Okay, I'm glad you asked. Here's the question in the book. And let's just read the problem. It says, consider the two statements. P, it's raining. Q, I will go to the beach. Write this. Okay, so let's go right to C. It says, assume that P is true and Q is false. So that means in a truth table, we're only interested in that line, Elliot, where P is true and Q is false. And then it says, find the truth tables for part A and B. Well, A was what? It's raining and I will go to the beach. So that's P and Q. And part B is, it is raining or I will go to the beach. So that's P inclusive or Q. So really all we're going to do is one line for each of those. What's the rule for and? Yeah, you might have to mute yourself, Elliot.
I'm
Some
sorry.
feedback coming from Mike. But anyway, if you do the and, the rule for that is only true when both are true. And since they're not both true, that is false. And for the inclusive or, the rule is only false when they're both false and they're not both false. So that one's true. So really, basically, all we had to do was a one-line truth table because they said they only wanted when P was true and Q was false.
Okay, I think I just misunderstood what it
Yeah.
was trying to ask. So thank you.
Yeah, it's a little different problem there. We didn't have to do a complete truth table, and you probably, yeah, it wasn't that obvious. Okay, those are two good ones. What's next questions?
I had trouble with 25
All right.
when the question asks or only true when or one is true or the other. I automatically went to the exclusive. It's just like I got stuck on the exclusive that's supposed to not be in the book.
Yeah, you're right. And by the way, I'm going to show you how the book expected you to do it also, but it was easier for us because we had that. So you're right. Number 25, here it is in the book. I go to college or I join the Army, but not both. You're right, Susan. That is perfect for the exclusive or. So you notice that's what I set out down here. I used the abbreviation for go to the Army, G, and the abbreviation for join the Army, J. So really they were asking us for G, exclusive, or J. And I don't know if you remember and by the way, they already told us right up here, look. They said, suppose G is false, J is true. So if you're here again, like I was just telling Elliot, this is really a one-liner. G is false, J is true. We don't have to do any other lines. What's the rule for exclusive or? Only true when they're different? And sure enough, they're different. So true, we're done. Now, I'm not going to do it, but this over here is what you would have had to do if you didn't know about the exclusive or. You'd have to say, all right, well, first do the inclusive or, G or J, and then you gotta do not both of them. And that can be written either this way or this way. And as you can tell, that's a lot of work. All because they didn't give you the exclusive or. By the way, it comes out the same. But I'm just not going to do it because it's a perfect application of the exclusive or. So yeah, you're right. This is a great example of how you guys are at a huge advantage having the exclusive or. The book, you got to do all kinds of horsing around to get around that.
I blew it on that
I don't
one.
know. Did I answer your question, Susan?
Yep, got it.
Okay. Another question?
Could we do 13?
You bet. Okay, so here's 13. Here it is in the book. See, I got to read the directions. In 12:16, let P be MITA is cooperative, and let Q be DESI is uncooperative. You see that up here? Okay, so what we're saying is neither DESI nor MITA is uncooperative. So isn't that saying both of them are cooperative? Okay. Well, P already says that MITA is cooperative, so that can be just plain P. But I have to do not Q on the DESI one because the Q stands for DESI is uncooperative. So not Q would stand for DESI is cooperative. So that's kind of a crazy one. It's all based on, you know, this beginning point up here in the directions. And it's a little negative. Anyway, we got to get used to that crud. Neither DESI nor MITA is uncooperative. Why don't you just say they were both cooperative? But that's the way the English language is. Another way to look at it is down below here. If you start off with, yeah, well, never mind. I'm just going to admit that. I probably will confuse things more than I'll help. Go ahead. Did I answer that question? Or was there a follow-up?
Well, that's where I got confused. Well, where you said not to show us later, the other part you had on there is because the or changes to and in the book. I didn't understand that.
Yeah, that's because, okay, well, okay, that's the meaning of this word here. What does nor mean? Nor means as in neither nor. So when this is just an English thing. What does nor mean? It means the first one is not and the second one is not. So there's an and implied when we use the word nor. That's an English thing. It has nothing to do with mathematics, right?
So it's and not.
Yeah, it's both of them not. That's what it means. Not the first one and not the second one is what nor means. And if you not them both, you know, I guess technically you're actually going to use what? If you look down here, you're actually using the De Morgan law when you're negating both of them. And you can see that it really does turn out to be what I showed before I uncovered that. So just remember, this really all comes down to what does nor mean? Not the first and not the second. And that's an English lesson. It has nothing to do with what I taught you. I guess we should have spent a little time with the word nor, but you know, as in he is neither late nor is he old. You're saying he's not either one. He's not the first, he's not late, and he's not old. So yeah, it's all in that. Too bad, because I don't want to spend too much time on English, but that's an English situation. Yeah, glad you brought it up. Other questions? Or a follow-up to any of the ones we've been talking about? Okay, we can always come back, but I'm sensing it's time to move ahead. So, I'm going to begin by just doing a little bit of reviewing. Okay, these are rules that we had last time, and I just want to kind of firm them up in our minds. Remember, this one was the first one I taught you. Well, first I taught you how to make how to make what? A grid, like this grid over here. How many rows do we need? Remember, I taught you this little rule, 2 to the n, where n stands for how many statements there are. So because we have 2 in this case, we need 4 rows. And then we do this, all right, first column, half and half, 2 true, 2 false, then go by ones, true, false, true, false. And then secondly, I started teaching you the rules, and the rule for and is true only when they're both true. The second rule we had last time was the inclusive or, the one with the big V, and that one was what? Only false when they're both false. So of the 4, you see the final answer column there only has 1 that is false. And you've been working on memorizing that, right? And then here comes the one that wasn't in the book, the exclusive or. And I said it was true only when they're different, meaning if the 2 individual truths are, if one, one's true and one's false, then it's true. But if they're both the same, then it's false. And you can see TT is false, FF is false, but when they're different, it's true. Another one from last time, this was the easiest of them all, the negation. Now with negation, you only have one statement. So n is 1. So 2 to the n power is 2 to the 1, and you only need 2 rows. So, and this is about, I mean, there's no easier rule than this, just the opposite. So those are the rules we had last time. We're going to be adding 2 rules to it today. And here's the first one. Well, at least, maybe not. This is the introduction. By the way, here's the title for this lesson today. It's lesson 3.3. You can get this out of the book too, but the title of the lesson is the conditional and the biconditional. And that if dash then is another name for the conditional. Sometimes instead of calling it a conditional statement, we can just call it an if-then statement. If you continue in my word, then are you my disciples indeed. Passage from the Bible. If you eat your fish, then you may go out and play. If the triangle has a right angle in it, then it is a right triangle. I mean, we do those all the time. Or if you filled out line 18, then subtract here, as in what? Tax form directions. So let me just explain briefly in the picture here, where we have I don't know if you can tell, but it's a picture of railroad tracks with a switch. So when you get to certain railroad yards where they need to move cars around, they can throw a switch and move a train from one track over to the other. So how does this fit if then? If the switch is thrown, then the train will turn. That type of, or if the light is red, then I will hit the brake. I mean, we use this all the time. So, okay, so let's dive right away into, first of all, the symbol for if then is the arrow from left to right. So do you see, good news, we only have two letters, P and Q, so we only need the standard 4-row table. And P arrow Q is read if P, then Q. So that's translated as if P, then Q. Now, go through my little story. I think you've heard this already, but I say to my wife, if I get out of work on time, then I will buy bread on the way home. Okay, now let's say I didn't get out of work on time and I didn't buy bread. Did I lie? No, because the condition was, if I get out of work on time, then I'll buy bread. So I didn't get out of work on time, I'm not expected to buy bread. Okay? What if I didn't get out of work on time, but somehow I bought bread anyway? Well, that I'd probably get extra credit for that. Okay? I went above and beyond. What if I did get out of work on time and I did buy bread? Well, then I told the truth. And then there's the bad boy. I got out of work on time, and instead of buying bread, I don't know, I gambled. I went and played cards and I gambled. That's the bad boy, right? So you see of these 4 lines, which one is the only one that's false? When the condition part, the if part is true and the then part is false, then that's a flat out lie. So I can't come up with a shorter little ditty this time, okay? It's maybe not so little, but there it is in the box. It's only false when the first statement is true and the second statement is false. So again, only one false out of the 4. And the only one that's false is when the if part is true and the then part is false. What is this now? Let's see, we had and, or. This is our 5th rule now. If then. Only false when the first one is true and the second one is false. Okay. And, the good news is there's only one more, new one, that is today, but still, that'll give us 6. Now, I have this little video. I think this should work. I'm going to try this here. A little video on that kind of goes along with this. Is a commercial you probably saw. You've all heard this, like somebody will say, let's see, I'm trying to think of an example. Are you happy about paying taxes? Or I'm trying to think of it. Are you going to support that president? Yeah. When pigs fly? Or when hell freezes over? We've all heard those. Well, let me run this, see if you can hear it, experience it.
Hey, Ralph, can I have a Dorito?
Sure. When pigs fly.
Hey, Ralph. Good boy. Hey, Ralph, can I have a Dorito?
Sure. When pigs fly.
So, I don't know if you guys were able to see that. Kind of a funny commercial for Doritos. Anyway, so the point being, pigs don't fly. Therefore, it'd be like if I said, If pigs fly, then I'll give you all $1 million next time I see you in class. I'm pretty safe, unless you play a game like this kid did on the video and, strap a rocket to a pig's back. So anyway, sometimes we'll put a ridiculous condition on just to show there's no way this is going to happen. Okay, so going on, here's the second one, the second new one. This one is called if and only if, or it's also called a biconditional. You guys are all there yet, right? Okay, everything's okay?
Yep.
I just had kind of a strange thing happen here. Okay, good. So anyway, we have if and only if, and it's called a biconditional. And do you see what the symbol is in the top of the table? It's a P with a double-headed arrow with a Q on the end. So it's kind of like if P then Q, and at the same time if Q then P. So it's like the arrow goes both ways. Now in math, you don't have to memorize this, okay? But I wanted to show you that in other math books, they will sometimes abbreviate this as IFF. You don't have to remember that, okay? This is how you're going to usually see it. You'll usually see it in the form of if and only if. And it literally means if P then Q and if Q then P. And well, I'm just going to flat out show you. Here's the results. It's true this time only when they're alike. So this is just the opposite of, you remember which one? This is just the opposite of the exclusive or. When it was true only when they're different, this guy is true only when they're alike. So, and here, down here, I just wrote that down, that this is exactly the opposite of that exclusive or. You don't have to remember that either, but it might help you remember your rules, okay? I mean, I'm not going to ask you a specific question, what's opposite of the other, but you need to know that when you're given a if and only if statement, the rule is it's true when both truth values are the same. So you notice TT is true, and so is FF. Just the opposite of the exclusive or. Okay, so now you've got 6 rules. And I'm going to run through all 6 of them again. Here we go. And the upside down, what, V, or whatever you want to call it symbol-wise. True only when they're alike. I'm sorry, only true when they're both true. Then we've got the inclusive or, the V. Only false when they're both false. Then we did that one that wasn't in the book, the exclusive or, the circle with the cross in it. Only true when they're different. And then last time, the last one we had was negation, which was just opposite. And now today we've added the if then, if P then Q. I'll put it on the screen here again. And it was only false one time. And that is when the if statement is true and the then statement is false. The other 3 cases were true. And then finally, the one we just had, the biconditional, the rule now is only true when they're alike. So that's it, by the way. There are not going to be any more than those 6. So I had told you to start working on your memory work. You really need to zero in on these. Now you need to add these 2 that we've added today. So hopefully you got the rules down, and I will. I'm pretty yeah. You'll see this is in the notes for today too. So if you didn't catch it, you can always look there. So what we need to do now is take these extra 2 rules, so now we have 6 rules, and basically practice them and do a bunch of truth tables. So let's see, we've been at it for about a half hour, so for the remaining 20 minutes, that's what we'll do. We'll do sample problems. So here's our first one. And you don't have to know this, but this is right from page 130 in your book. And what they're saying here is, show me that the biconditional, P if and only if Q, that one right there, show me that that is equivalent to if P then Q and if Q then P, like I told you a few minutes ago, that it was literally if P then Q and at the same time if Q then P. And the way to show that it's true is we're going to do a truth table. Well, the good news is, despite all the letters here, there's still only 2 letters, P and Q. So it's a standard 4-table setup. Well, should we do the easy side first? So on the left, we have to do if P if and only if Q. That's the one we just learned, right? And the rule for that is true only when they're alike. So I know here they're alike, TT. Here they're alike, FF, and the other ones, they're not alike, so those are false. So there's the left side of this equivalence. By the way, do all of you remember this symbol from last time? When an equal sign with an arrow on each end, that means equivalent, and it's like it's the left side is equivalent to the right side. So now we got some work to do. So first, let's do this parentheses. If P, then Q. That's a new rule too. Remember how that works? Only false when the first one is true and the second one is false. Do you see that's this row right here? That's the only one that's false. Well, now that I know that, the other 3 have to be true. Now, can you think backwards? Because we need to do this set of parentheses next. If Q, then P. So you got to eyeball backwards. Q comes first and then P. Got that? So, and you know, this is the same rule, only false when the first one is true and the second one is false. But the first one's on the right now. So can you see that's this one? This is the only row where the Q is true and the P is false. You know, because it's if Q, then P. And the other 3 are true. Okay, we're almost done on the right side. Now we need to do this guy. We need to connect them with the AND operator. And the AND operator was what? Only true when they're both true. So this line, they're both true. This line, they're not both true. This line, they're not both true. This line, they are both true. Now, did it work? Well, this row with the arrow should be the same truth value as that one, and you can see that they are. So we have just proven they really are equivalent. That's the idea of equivalence. Show that the truth table ends up with exactly the same results on both sides. And we made use of both of our new rules in this problem. So it was kind of a good way to practice our 2 new rules. Anybody have a question? Okay, I'm going to move on. Let's do, yeah, here's a really good one. In fact, this one's going to turn out to be really important as we move on in the chapter. So the idea is, you see it up here, it says prove the following statement. Prove this. How do you prove 2 things are equivalent? We just learned how to do that. Show that both sides on the equivalent sign come out the same. Okay, well, let's do the left side first. If P, then Q. That's a new one we just did A. Only false when the first one's true and the second one's false. By the way, if you're wondering why is there a not P here, it's because you know, I'll tell you what, I'm going to take it out because we can put the not P, excuse me for this. We can put the not P over, I'll show you, we're going to handle it in a different way. Okay, so if P then Q, only false when the first is true and the second is false. There it is, right there. When the first is true and the second is false. The other three are all trues. Okay, left side's done. Now here we need a not P. Let's put the not P in right here. Okay, so if P is TTFF, then what is not P? The opposite, right? So this would be false, false, true, true. Just the opposite of the P column. And should we make it a little easier? Let's copy Q over here too. Q is TFTF. And now we have to connect them in between here, and we have to use the inclusive OR symbol. What was the rule for that one? Only false when they're both false. So that would be this one, right? Here they're both false, so it's anything else, it's true. They're not both false, they're not both false. Now compare. Are they the same? TFTT. We did it. We proved it. So here's another example of an equivalence that you've been asked to prove. That just means show that both sides come out exactly the same. Again, I don't know if I'm going too fast, so I'm going to pause, see if you have any question here. Anything at all?
How do you know when looking at the statements in symbol form? How do you know when to use the inclusive OR?
When you have this symbol.
Isn't that the circle with the cross in the middle, or am I getting it?
No, that's the exclusive OR.
Oh, exclusive. Okay, my bad.
That one's exclusive. This one is inclusive. So that's how you know. It's the symbol. Now, did I really answer your question?
Yeah, I got the terms.
Yeah. So, you just reminded me of another thing, Elliot, with your question. And that is that besides memorizing the rules, one has to memorize the symbols too. Yeah. And that's good. That's good that we needed to be reminded of that. Okay, let's go to another example. Here's one of the problems from the assignment. It's number 16 on page 133. And again, I'm going to erase the not Q because I'm going to do it a little differently. So the good news, so we're supposed to make a truth table for this, okay? And the good news is we only have two letters here, P and Q. So praise the Lord, we only need 4 lines, and we've got the standard, setup here on the left. So there's nothing new there at all. Now, please note, this is not an equivalent symbol. Does everybody see that? Remember, what does this mean? That means is equivalent to. And we've been doing that. But what does this mean? Brand new today, with a single horizontal bar, that's biconditional. Okay? And that's what we have in this problem. It's the biconditional. So, yeah, symbols, again, I'm reminded, symbols are a big deal. Okay, so let's do the left side. If P, then Q. New rule today. Only false when the first one's true and the second one's false. The other three are true. All right. Now let's do the second set of parentheses. And for this one, I'm going to put some letters in here. I'm going to copy the P over. True, true, false, false. But over here, I want to put the not Q, the opposite of this. Opposite of TF is FT, FT. All right, now it's kind of sloppy. Now follow this rule, the if-then rule. Only false when the first one is true and the second one is false. So that one right there is false because the first one's true and the second one's false. This one, nope, it's not that, not that, not that, right? The only one on this list where the first one was true and the second one was false was the top one. All right, now take these two, this one right here and this one right here, and connect them with the biconditional. And what's the rule for the biconditional? Brand new today. Only true when they are alike. So TF, they're not alike. FT, they're not alike. TT, they are alike. TT, they are alike. That's our final result, and so that's the one that gets, you know, the big arrow or whatever, the indication that that's our final result. Now I know it's a little bit maybe puzzling. You guys are, we're really pushing these new rules today, and I know you just learned. So, but still, does anyone have a question on that one? So, see, this is not an equivalent now. This is an operation. Whereas, that's somebody trying to ask a question. I didn't get it. Try it again. Somebody accidentally hit the mic. Was there somebody trying to ask me a question? So please note, if we look back at the last one, this is not the same as, this is actually like an equal sign. Are the two sides the same? As opposed to this problem, this is no equivalent sign. This is an operation that says if and only if. So you notice on this one, we don't have anything under the equivalent symbol. We're just checking if the two sides are the same. But here, because this is an operation here, not only do we have answers, it's our final answer. So that takes a little while to get used to that, maybe. Okay, let's do another. The more we can do, the better. That's, all right, let's do this one. Now, by the way, I think this is 18 on the assignment. So let me just erase a few stray asterisks here. And this is what they're asking us to do. I'm going to turn back to red here. This is the problem. It says make a true table for that. Notice we have three letters, P, Q, R. Therefore, we have to do 2 to the 3 power, or 8 rows. So if you were wondering why does it have so many rows, that's why. And so, P, all right, we got 8 now. So the first column, go half and half. T, 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 F, 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 F. Second column, cut that in half, go by 2s. T, T, F, F, T, T, F, F. Third column, cut 2 in half and go by 1s. TF, TF, TF. All right, we got it set up. Do you know how this works? You got to do the parentheses first. So let's start with the first one here, huh? If P, then Q. New rule. How does that work? Only false By the way, we're doing only PQ, so you got to ignore R right now. I'm going to put asterisk here. Right now, you're just looking at those two red asterisk columns, so got to be selective with your vision. Only false when the first is true and the second is false. So here we have true, 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 true. Here's a bad boy, right? If true, then false, that's false. So is this one. If true, then false, false. If false, then true, we're good. The rest of them are all true because none of them, the rest of them don't begin with a true. All right, so first column done. Now let's do this one. Next parenthesis. I'm going to get rid of the asterisks. And now what are we doing? Only P and R. So I'm going to mark them with an asterisk. Those are the two columns you're looking at. Okay, can you selectively look at those? Again, the rule is, I can't know if I can't get rid of that other stuff. So I was going to erase those red lines, but I can't. Okay, so the rule is only false when the first is true and the second is false. True, true, we're good. True, false. See that? There's a false in the R column, so that's a false. True, true, we're good. True, false, that's false again. False, true. False, false. Whoops. False, true. False, false. Only false when the first is true and the second is false. Okay, now we're almost done. All we got to do is this guy. Now we have to AND them together. That was a rule from last time. How does that rule work? Only true and they're both true. So if true, then true. Good. If true, then false. They're not both true. False, true, not both true. False, false. They're not both true. True, true. They are both true. True, true. They are both true. And likewise, these last two, they're both true. So that's our answer column. That's the end of that problem. Again, I know this, I'd rather do this together with you, but this is better than going 4 lessons a night. Any questions? I think I'm going to try to do one more with you. So really, just let me remind you what we're doing. All we really added was 2 rules today. The new if-then arrow rule and the double-headed arrow if and only if, or the biconditional. And then we're just practicing all the rules thrown together. Yeah, well, I don't have my book, so I can't read that. I guess we'll hold it at that. The assignment, I believe, is already posted, but let me get that out. So on the 3 point, this is 3.3, 1 through 57, the odd numbered ones. Now, let me go back. Did anybody want to still ask a question on the assignments that were for today? The 3.1 or the 3.2? Or maybe I should have first said, do you have any questions on the slides I just showed you? If I hope I go too quickly. So now, another nice thing about the videos, they have the old pause button and you can stop it and just freeze it. And if I went too fast, I'm sorry. At least you can overcome that way. But did anybody, got any more? You guys had good questions today. Are there any more that you can think of? So as usual, I gave you 2 assignments Wednesday. I added one today. So when we come to class Wednesday, you've got 3 assignments. And we can open up questions on all 3 of them before we move forward. Try one more time. Anybody have any questions out there? I'm not seeing any, and I'm not hearing any. So I guess we will close it up. I'll post the video probably within 10 or 15 minutes. Thank you. Hope you have a good Sunday evening. Boy, is it nice to have sunshine again.
Oh, yeah.
And I'll see you on Wednesday. Did somebody have a question? Okay.